Hello dear students, welcome back to my lesson. In this video, I'm going to explain the centripetal acceleration for circular motion. For example, when an object is moving in a circular path, this object experiences an acceleration. So the type of the acceleration will be centripetal acceleration always and tangential acceleration sometimes. Why? Because the tangential acceleration is the acceleration of an object that produces during the variation of the speed of an object or the magnitude of the velocity of an object. Okay, but in the case when an object is moving at constant speed in a circular path, this object has no tangential acceleration, but it has centripetal acceleration. So the centripetal acceleration we can calculate by using this equation. AC is equal to V squared over R. This equation can be used to find the centripetal acceleration. So the centripetal acceleration is the acceleration of an object that experiences during the circular path. Because the velocity is a vector quantity, it has both magnitude and direction. Okay, so the producing acceleration during the variation of the direction of the velocity is centripetal acceleration, but the tangential acceleration is an acceleration that produces during the variation of the magnitude of the velocity. Okay, so velocity is a vector quantity. Velocity, it has both magnitude and direction. Okay, so in the case when the magnitude of the velocity changes, the tangential acceleration will be produced for that object. But when the direction of the velocity changes, the centripetal acceleration is produced. For example, if you draw a figure, okay, so assume that this is car, okay, okay. If the car or if the object is moving at constant speed without changing the speed, in that case, the type of this circular motion is called uniform circular motion, because we have two types of circular motion. Uniform circular motion, which is the speed of the object doesn't change, and non-uniform circular motion, which is the speed of the circular motion or of the speed of the object in a circular motion changes. Okay, for example, if the speed of this object is 5 meters per second, okay, so it's directed into this direction. The tangential speed, which is tangent to the circular path, and also the tangential speed is 5 meters per second, but in that case the direction of the tangential speed is downward. In the first case, the direction of the tangential speed is to the east, but in that point the tangential speed for the object is downward to the south, and at this point the direction of the tangential speed v is to the west, which is 5 meters per second. So at this point the tangential speed is directed upward to the north. For example, v is equal to 5 meters per second. Okay, so if you see the figure, you can see that the magnitude of the velocity doesn't change. What do you mean by if, for example, if the object is with the magnitude of the velocity doesn't change, it means that this object has uniform circular motion. What is the type of this motion? Uniform circular motion. Why? Because the magnitude of the speed doesn't change. Okay, but if you see, the direction of the velocity changes continuously. Okay, so that is why this object has centripetal acceleration, and this is the axis of the circular path or rotation. Okay, so this is the distance from the axis of rotation. Okay, and you can calculate the value of centripetal acceleration by using this equation. Okay, and be careful for an object, for example, when it's rotating, any point on the rotating object undergoes a circular motion. Okay, and because there is a relation between the tangential speed or linear speed with the angular speed, which is equal to v is equal to omega times r, okay, and v squared is equal to omega squared r squared. If we substitute into this equation, so we can get a new equation which is equal to, instead of v squared, write down omega squared r squared over r with r cancel. What is remain? Omega squared r. Okay, so when does AC is equal to, look, when does AC is equal to omega square? In that case, when the object is rotating, for any point on the rotating object has a circular motion, which means that has a centripetal acceleration. But actually, the rotational motion has no centripetal acceleration. Be careful. For example, rotating Earth around itself. The rotating Earth around itself is a rotational motion. The Earth is rotating around itself, has no centripetal acceleration, no centripetal force. But every point on the Earth has centripetal acceleration. So when does this equation can be used? This equation can be used to find the centripetal acceleration for an object on a rotating body. Okay, so in this case, we can finding the centripetal acceleration, which is related with the tangential speed and the radius of the circular path. With the velocity, with the tangential speed, centripetal acceleration is directly proportional. With the radius is inversely proportional. Okay, that's all for today. Hope you benefited from my lesson. Thank you for listening.